अब ठीक है, चलो डाल दो, फिर मैं लाइव करता हूँ यहाँ से। ताबिश अपना कैमरा ऑन कर लो। ठीक है, आई एम पुटिंग इट लाइव।
हेलो
हेलो।
यार मेरे को है।
All right. Okay. A very good evening to everyone present for this webinar. Welcome to this webinar on astrophysics presented by Learnivio. Learnivio is an online personalized learning platform which provides personalized learning for classes 9 to 12, and we prepare students for IIT, JEE, NEET, and school boards. As part of our learning, we also have futuristic courses where we teach students on different aspects of science which apply these concepts of science. So Mr. Tabish Shibli is an MSc from Tata Institute of Fundamental Research and is also an ex-teaching assistant at Ashoka University. We're very honored to have you, Tabish sir, with us. Please take the mic from me.
Thank you so much for that introduction. It was lovely. Welcome everyone, and hope we're going to have a good time today. So let me just start sharing my screen. If the host could make me a co-host, I'll be able to share my screen. Not able to share my screen yet. Thank you so much. Okay, so I hope my screen is visible to all. And welcome again. So this is an introductory lecture. It's just supposed to give us an overview of essentially how things are going to proceed in this course on astrophysics here at Learnivio. We're calling this course a simple tour of astrophysics. I am your presenter, Tabish Shibli, and as you've been informed about me, I am a master's and I worked in teaching before as well. Now, first of all, let's talk about the aims for the course. The aim or the idea or the philosophy behind this course is twofold. First, we as humans have been looking up since childhood, looking up at the night sky just in awe and wonder. And the same thing was done by our ancestors. And the amazing thing is, since the night sky has not really changed much over the past millennia, we are actually seeing more or less the same objects that our ancestors saw. So according to me, it just becomes our duty to actually answer their questions, their deep felt questions of what we're looking at. What are these amazing objects, many different objects which are behaving differently. Some are twinkling, some are not. Why is this happening? Some objects tend to move in one direction and just reverse in direction. For example, the orbit of Mars. All these questions have been at the back of human civilization for a long time, and we essentially through this course help you in somewhat answering those questions, and even more. Secondly, a bit more of a utilitarian approach to things is what we here at Learnivio understand is best. Already a jam-packed and intense environment that you kids have to deal with. I mean, there's not much to say. Enough has been said about that. Maybe a more hands-on approach, that is why we think, or an application-based approach is what is actually going to change the system and look at the same world that we all have been seeing from a different lens, from a new lens, from a new way of thinking. We will indeed be touching with the syllabus, mostly physics based, because it is a dominantly physics based subject. So questions of like orbital motion, questions of thermodynamics, of stars, and interesting things on electromagnetic radiation. We'll be touching on all these subjects, and even in today's introductory lecture, I'll exactly tell you at which lecture is essentially pointing to which part of your syllabus. So essentially, we will need our pens and papers here. So do not forget them in your next class. We will also be looking at multiple graphs because that is a very, very big part of our education, especially the 11th and 12th exams. Graphs are something that can make your life very easy or literally hell. Because if you understand how any function looks in the form of a graph or behaves in the form of a graph, things become very simple. Things become very, very efficient. That's something that we will look at through some examples that we observe, and we also might end up doing some experiments by the end of this course. So two things: understanding the night sky and understanding the objects in the night sky, from the solar system to the universe. Now, moving on, what is the need for this course? As I said, we already need a multi-pronged approach to education. A lot has been written about education, a lot has been said about education, but it's all on the same approach of, well, you need to learn things, you need to memorize things. But however, there is, if you're able to see an object from multiple points of views, I think that is what a future economy needs. And that is essentially where Learnivio is trying to push our students towards. And secondly, just get it out there. Just go out, just look at the night sky, just look at the moon. Moon is overlooked a lot. The moon is beautiful. It has beautiful craters. It has its shape changes throughout the month. A lot of things to know. The color changes, which we will again come back to in one of the future lectures. Okay, so step one, stargazing, looking up essentially. So we will essentially take a couple of lectures to cover this part of the course, which is essentially related to stargazing, and we'll hopefully start this next week. We will start with stargazing because that's essentially the first thing that one should that's the first step towards knowing what is up there. Just go out and look up in the stars. But not only that, you will realize that there is a whole community out there of stargazers and star photographers, which essentially go out during the night sky to take these wonderful and beautiful photos that we see all around us on the internet. So if you're interested in going out and getting dirty, the next class will be an introduction on exactly that, where we will talk about not only what they do, but also the resources needed to essentially get your own journey of star tracking going on. We will then continue on in this lecture. The second lecture will essentially deal with more the movement of stars and locating certain important objects in the night sky, certain constellations, certain important. So for example, the center of the Orion belt. A lot of you must have heard this very, very common constellation that people talk about. The center of the Orion belt, the belt itself, the three stars which are in linear formation, if you actually look a little bit below the belt, you'll see a small patch of bright light. That is essentially a nebula. That is the Orion Nebula, where stars are essentially found. And we learn more things about constellations, that not see when you're sitting on Earth and when you're looking out, all of this is just a two-dimensional projection of three-dimensional universe, right? So these constellations that we see, the stars in those constellations actually might be millions of light years away. They might be very, very far away. But because it's just a 2D projection, we see them together. So all of these things we will be able to see through multiple softwares that we're essentially going to use, and we're going to analyze these topics in much, much more detail. So the first class will be essentially be related to stargazing, and then we'll move on to movement of stars, planets, and the moon, and some important constellations to know your way. Constellations can also be used for many different things. For example, just checking your direction if you don't have a cell phone and if you're lost, just to know where north is from south. It might help you save your life. So there are some good things about knowing what is up there. Then step two, knowing the universe. So the solar system, so the third lecture, we're essentially going to deal with the solar system. So we're going to go scale by scale. First, we're going to talk about the solar system, then we're going to talk about galaxies, and then we're going to go up another scale and talk about the universe as a whole itself. So when we talk about orbits, when we start talking about orbits, that's the first connection to your syllabus that we see, which is orbits. We do a little bit of a little bit of Newtonian gravity. We calculate a bit of orbits, we calculate time periods, we calculate frequencies, and then after doing all those tricks, we actually try to go ahead and actually match if our calculations are actually matching with this with what the softwares are telling us. Though these softwares are actually just seeing the night sky and just reporting where the stars are, so it's not really different from seeing the night sky. But still, it's an interesting experiment to do, and one should do this once in a while. Then actually going ahead and defining planets and moons. So what are the basic definitions of these things? Because things can get very technical very quickly. So we'll try to be nice about things. We'll still try to be very very precise about things. Next is our second connection with the syllabus, which is the colors and shapes of the moon. Especially when we're talking about the colors of the moon, because the colors of the moon are essentially the different colors of the moon are, are made because of different climatic conditions within the Earth's atmosphere. And this essentially is a lot of direct questions from the electromagnetic waves and how they essentially travel through mediums. All of those questions come up. Optical questions comes from this particular topic. If you understand what the basis of these distinctions are, because essentially the moon is ever present, right? So all the different colors are essentially telling us all the different states of atmosphere that we're witnessing. So all the states of the atmosphere can just be defined by the different colors of the moon. So it's an interesting take on atmospheric physics itself. Then we'll go ahead and talk about something called the habitable zone, and then we'll all contemplate on whether alien life can exist or not, and questions of those nature. We'll take a couple of classes, essentially doing this whole thing, and then finally we're going to talk about the different moons in the solar system, which is actually the most interesting topic there is to look in our own solar system, because these moons can get very very exotic, from tiny moons which are going around Saturn and spraying out water of all things. They're literally spraying out water, and the water gets ionized, and hence the orbit of Saturn, the rings of Saturn get disturbed. So all of these things, all of these interesting facts, we'll essentially contemplate on these things and try to learn the origins of some of these things. The next, we're going to talk about stars and galaxies. Here is the next connection with a course, which is essentially the thermodynamics of stars themselves. We have a basic understanding of how stars work, right? There is gravitational pressure that's pulling everything inside, and there is a thermodynamic pressure, or the heat that is inside the star, which is essentially keeping it stable. But we'll try to delve in a bit deep. We'll try to bring in some numbers. We'll try to do some calculations to actually get the gist of the problem, and what the problem actually is, and what other things can actually be driven from doing this kind of an analysis of just using basic thermodynamics and nothing else. Then we come to another part of our course, which is also again a part of our syllabus, which is nucleosynthesis. So anything above height. Yes. So, do you have a question? Somebody has a question? No. Okay. So, apologies. So, let's continue. So, yes, nucleosynthesis. So everything after hydrogen and helium, all other heavier elements, are essentially not formed at the beginning of the universe. They're formed later on within these stars, and we'll essentially try to know exactly what that chain is, which essentially led leads to all this diversity in elements that we see all around us, about 90 different elements which are not man-made, another 15 which are. We learn how most of them were predicted, not all of them. Okay, then we go ahead and talk about the shapes of galaxies and velocity curves. It's a fancy little name called velocity curves, but these are actually very interesting things and very simple to understand what these things are. However, the shapes of galaxies are actually a bit more technical and a bit more advanced. However, we'll try to explain how these formations actually happen. Um, these, okay, yes. So we'll take care of this when the time comes. Next, we're going to look at the Andromeda and the Milky Way galaxy. Andromeda, as some of most of you would know, is the next door neighbor to our own Milky Way galaxy. And some of you might further know that they're actually coming together and colliding. So in the next million years or so, we hope to see a lot of firecrackers in the air, which are essentially stars falling inside each other and and showing us fireworks in the night sky and glowing the night sky. And that's going to happen millions of years later. So let's not really worry about that yet. Next, finally, we're going, not finally, we have another topic after this, but here we're going to talk about, in the next two lectures, we're going to talk about galaxy clusters and the universe itself. So galaxies turns out like to stick together, like most things, and hence forms these clusters of galaxy, which are aptly known as galaxy clusters. And they form these thread like web-like patterns throughout the universe. And we'll try to look at those patterns and try to see the scales of those patterns. What are the biggest holes that we found, the biggest chunks of matter that we found, all of those interesting details, tidbits of details of these things. Then we come to another phenomena, a bit of a technical phenomena, but a phenomena that is worth understanding, which is gravitational lensing, simply because it's used so heavily in the media, especially when simply because whenever you're looking at something far away, a far away galaxy, this is essentially the method that you use to look at that galaxy. So we will be talking about gravitational lensing, for a bit. From there, we'll actually get our hints of dark matter and dark energy, and that is where we'll take our conversation from there. We'll actually go ahead and talk about dark matter and dark energy, what we speculate these things are, what we know about these things, and what we do not know. So we'll get some future projects as well, maybe from this course. And finally, we're going to talk about some exotic events in the universe and their uses as well. So, exotic events like pulsars and quasars, and things you might have heard of, supernovas and black holes. And but not only what they are, but some of them are actually quite useful. For example, pulsars, since they pulsate in a very known frequency, we can actually estimate how far away or how fast it's moving away from us, and hence look at how far away the pulsar is. Very important instrument of detection of distance in the night sky, and we'll actually also learn why it's so difficult to measure distances in the sky. It's actually not that easy. And the other thing that we use to look at distances are essentially come in supernovas, and that's where essentially we're going to talk about that, and we go into some details about each of these things. Now, next, okay, so these are some softwares that we're going to use. It's actually good idea. Most of these softwares are free, but it's always a good idea to get your own software. So Stellarium is like a basic. I mean, everybody in the astronomy community or anybody in the stargazing community uses Stellarium. Stellarium is for both Windows and Linux. It's a lovely software. You can look at how the stars are moving. You can there's a good enough catalog of, not a very good catalog, but a good enough catalog for especially beginners of the object in the night sky. So if you click on each object, it will actually tell you all the information about that object as well. Other apps are Star Walk 2 or Star Tracker, which is available on Google Play and Apple Store, respectively. And then there are Google and Apple's own versions of these Sky apps. So the Google version of this app is called Google Sky Map, and the Apple version is called Exoplanet. Okay, so yes, so this is essentially a very experimental form of of teaching that I'm going to try. But I'm trying to so what I'm going to do is try
Okay.
to explain the formation of a star, but using pictures. Why using pictures? Why am I doing this? Well, I mean, I was trying to get a video, but wasn't able to. So go did the next best thing, took photos, and actually made an experiment out of it. So yeah, okay. So what you're looking at right now, this photo is of the Orion Nebula. Remember the Orion Nebula we talked about in the starting? This same Orion Nebula, which is below the Orion belt. If you zoom in, this is actually a photo taken by Hubble, the Hubble telescope. We got it from New York Times, but this photo is available throughout the internet. But if you zoom in on this, you see these tiny bright objects. What these bright objects are essentially small stars that are being created. Tiny proto stars. So what essentially happens? There's a lot of gas, and gas under its own weight starts collapsing and starts coming together. And since there will always be some angular momentum that will be present. So this whole thing starts rotating along an axis. And what happens is that these tiny things, which are essentially rotating inside, they start moving. So here you can see these droplet kinds of shapes. These are essentially stars. So these stars are going through a lot of radiation which is coming from other nearby stars, which are immense stars. So big stars essentially produce a lot of radiation. So hence any star that is moving, a newborn star which is moving near any other stars, which will be forced on by a lot of radiation, and hence will form this droplet-like shape, which actually you do see through through telescopes. And so this is a bit more zoomed in view of the exact same thing. So this is again the same star which is moving in a lot of radiation. This is how it looks like on the inside. So inside this whole sphere, you have this center, you have this massive center, a lot of energy, a lot of heat, and a lot of matter just rotating around it at very high speed and forming a disk. It's starting to form that disk formation that is very familiar to us. Here is another photo, a bit more close up of exactly the same phenomena. Uh, then the star essentially just keeps on going in space. It moves out of the nebula many times they don't, um, but most of them do move out of the nebula and they become cold, and then they start collapsing Hello, am I audible?
Yes, sir.
Oh, lovely. My thing went away. My internet just went away for a second. Just came back. Apologies for that. So yes, where were we? Yes, the star is cooling down, and this star cool downs, and matter starts coagulating in these ring formations. Why are they coagulating? Because of electric attractions, right? Because some of them get positively charged, some of them get negatively charged, and they just come together, and they just attach to each other.
And then gravity helps that even further, because once these clumps start forming, you have gravity, which essentially holds many clumps together, and hence form planets. And first, it forms this kind of a shape, which is essentially something like Saturn's rings. Not exactly the same phenomena, because there is something more interesting that is going on in Saturn, not because there's something going on here, but very similar effect. These waves of dense, very dense layers, and um, very dim layers you see all around, and then along each of these orbit, they collapse together and form the solar system. And that is, my friends, how the solar system came into being. Thank you so much for listening to me for this long. And questions, yes, questions are recommended. So let's.
So basically, this is something out of the course which you do for yourself, right?
Yes,